Welcome to the online training for hardcoat stucco. These first two modules are on lathing. The professional lather is a tradesman possessing a unique skill set and a rich history. Lathers are critical to the success or failure of a hardcoat stucco installation. The professional lather goes well beyond a worker who just puts up lath. A professional lather understands how flashing works, the backing that is needed, and sets the foundation for a successful stucco project. Historically, it was the lathers who were the flashing experts. Many became estimators and general superintendents due to their ability to read plans, superior knowledge of weather protection, and expertise in framing issues. Good stucco depends on quality lathers who are productive, professional, and educated. The first two modules will explain flashing and how stucco works to keep water out. We'll look at key locations that need flashing to help you ensure the stucco functions as it is intended. We, of course, will cover lathing. We'll look at the backing requirements, types of lath, and various attachments. We'll look at the tools used by the professional lathers. These modules go beyond the basic and simple application of lath and include tips from professional lathers who have decades of experience to help you become a better lather. We will then look at trim accessories, commonly used for stucco, and cover the various caveats. We will look at regional practices around the United States. After the completion of these two modules, a test will be offered for those wishing to hold a certification of completion for lathing of stucco. The rules for installing lath are the building code, ASTM standards, and typically include manufacturer's requirements for installation of that product. Chapter 25 of the building code covers stucco. The code references ASTM standards. The ASTM standard for lathing is C1063. It would be impossible to cover all the required items in the code and ASTM. Your office should retain a copy of these standards for reference. These two modules will cover the basics and then go into specifics for installations, material recommendations, and various caveats. Our focus is not merely code compliance, but on how and why stucco works, and then how to avoid failures. Moisture management is a critical component for hardcoat cement stucco. There are three basic methods for managing moisture for stucco: the barrier, the concealed barrier, and rain screen. These terms should be familiar to you from the short introduction video on the SMA website. If you plan to take the test, you will need to review the introduction video. This training course will focus primarily on the concealed barrier approach, as this is the most widely used assembly in the United States. The materials used in lathing are varied with many options. You must use what is specified by the architect on the plans and specifications. While there is a wide variety of products for lathing and many regional preferences, your company is bound to use what is specified by the architect on the plans or in the written project specifications. The plans or blueprints will contain valuable information, such as the architect of record or the building code being used to build the structure. Inside the plans, you'll find sheets on the elevations and what the architect envisions the building to look like. You will also see notes and references to other sheets and details on how everything is to go together. However, you will likely find little information on what lath or other products are to be used. This will likely be contained in the project specifications and under Part 2. Most specifications have language trying to describe the products generically and then list the products that comply with that language. Use only these products unless your supervisor approves alternates. There are many options in water-resistant barriers for lathers. The most common are building papers and felts, house wraps, tape sheathings, and fluid-applied membranes. The choice is often clearly specified. We'll cover the basics for sheet goods. We'll refer to them as building paper for simplicity of instructions, but we can also be referring to any house wrap product. Fluid-applied membranes will not be covered and must be installed per manufacturer's training classes. If the manufacturer of any product we cover has an alteration or stricter requirement than the SMA training class, follow that manufacturer's guide for their product line. Asphaltic saturated paper and felts are commonly used for stucco applications on framed walls. The asphaltic papers have proven to be uniquely suited for cement stucco. Cement plaster, also known as stucco, is most commonly applied over sheathings. The sheathing provides a flat background. The lather then applies the water-resistant barrier to the sheathing. Many options are available, from 2 layers of paper to house wraps to specialty wraps made specifically for stucco. In this example, we'll look at what happens to stucco applied over an asphaltic paper. We would think this would result in a uniform thickness of stucco. Cement stucco is unique to other sidings. Stucco applied, as explained, should be uniform in thickness, but this is not what we find when we take stucco away from the asphaltic paper. The backside of the stucco is always wavy. We can see that the waves leave small gaps between the building paper and the stucco. How and why does this occur? The asphaltic paper has an inherent and unique quality when it comes in contact with wet cement. As the fresh cement plaster is applied, the paper will absorb a little of the moisture. As the paper absorbs some of this water, it causes the paper to wrinkle, pushing the soft plaster to form the waves. As the cement plaster hardens, sets and cures, the paper will also dry out and return to its original semi-flat state. Because the paper is soaked in asphaltic oils, the paper debonds from the stucco. The result is small gaps between the asphaltic paper and the stucco. The gap is small but effective. A larger drain cavity can be assured by using a rain screen mat designed for stucco. House wraps made for stucco that have wrinkles built in can also be used, but still require a multi-player approach with sheathings. This multi-layer approach has 3 built-in defenses against moisture. The first and foremost is the properly applied cement membrane that will repel or deflect over 90% of the rain. We acknowledge that a small or incidental amount of water must be anticipated to find its way past the membrane. Most of this water is absorbed into the back of the cement plaster. This is why some call stucco a reservoir cladding. This small amount of water will not hurt the cement plaster and will evaporate as the sun warms and heats the wall. The water turns to a vapor and escapes. This also explains why the SMA is not encouraging people to use non-vapor permeable coatings applied to stucco surfaces. The final defense is the weeping of water. Water can now weep down through the gaps created by the wrinkling of the building paper. The underlying house wrap provides an additional layer of protection against moisture entry. This process also explains why some designers prefer a drain mat in wet or non-drying environments. This is because heavy rains with low number of drying days can benefit from a rain screen type drain. The SMA recognizes both methods work and encourages the use of mats in wet or low drying environments. The concealed barrier approach for moisture management of stucco depends on what is called the shingle fashion installation. This is similar to how shingles are applied on the roof. Upper layers overlapping lower layers to ensure water is always directed down and out. This can be more challenging for walls as we have so many more complex penetrations than roofs. It is critical that you install your house wrap or paper, that you tuck it up and under sill flashings, and that you lap the paper over at head flashings. This is shingle fashion principle is of paramount importance for stucco to function properly. Tools are important to all professionals. Good tools can make the difference in production and quality of work. You should buy only quality tools. Every lather should have these tools as a basic start set. The lathing shears are invaluable to a lather. The extended handles speed production and help prevent cuts. The lathing hatchet is used to shape and attach lath. The handle may be made of wood or metal. Tin snips are used to trim and cut flashings and lath. They are also good for very tight areas. Every lather should have a set of end cutter pliers. These can cut wire easily and can be used to twist tie lath when it is needed. The hammer tacker stapler is a must. They need not be expensive or bulky to work. They attach papers or house wraps to wood framing and sheathing. This is the professional lather's tool set. These tools are your livelihood, and quality tools will help you lath properly and more efficiently. Every lather will customize his own tool set. A customization example is the modification commonly done with the hammer tacker. Many lathers insert a cutting blade to the back of the hammer tacker. This is done by inserting the blade between the rubber and the handle and wrapping it tight to secure the blade to the handle. This modification allows the lather to cut the roll open, trim waste, and apply paper more efficiently. The tool becomes not just a stapler, but allows the lather to flip the tool and cut the paper for greater efficiency. Cutting and attaching paper should be done with caution and only done by experienced lathers. Care must be taken as the blade is always present and will cut easily. This is why lathers need to stay focused. Avoid distractions, such as using headsets and listening to music. This is part of being a professional lather. Never allow yourself to be distracted. Stay focused and alert at all times. Using your tools requires using them correctly and carefully. This modified tool also allows you to cut paper against established plaster grounds, and they can be a guide for a clean, straight line. Again, pay attention to your task. You could potentially damage the window, door, or even yourself by a careless move. There are many laths available for use with stucco. You should become familiar with all of them. Some are better suited for various substrates or may have regional preferences. Welded wire is a lath that comes in 16 or 17 gauge wire thickness and works well on both wood and steel framing. Plastic lath is a newer innovation that is commonly used in Florida. It is very suitable for concrete and masonry substrates. Expanded metal lath is rated by its weight. It comes in 2.5 and 3.4 pounds per square yard. Both are suitable for cement plaster over all substrates. It should be noted that 1.75 pound lath is not appropriate for stucco. Woven wire comes in 20 and 17 gauge wires. Sometimes wrongly called chicken wire, it is popular on the West Coast, code compliant and suitable for all wood frame structures. Rib lath is an expanded metal lath that has ribs to add stiffness to the lath material. The ribs may be flat or high rib. They are best used only on soffits or ceilings applied to open joists. The ribs allow the lath to span open joists and provide rigidity needed for the plasters to apply the cement scratch coat. Fasteners will vary as much as the laths used. It is important to select the appropriate fastener. The lath and the substrate will dictate the fastener selections. Staples are appropriate for all laths on wood frame structures. They must penetrate wood framing a minimum 3/4 of an inch on walls. Powder actuated fasteners are recommended for laths to be attached to concrete or masonry substrates. They must also penetrate a minimum 3/4 of an inch and provide a minimum 50-pound pull-out value per fastener. Screws with large wafer heads are used for attaching lath to steel framing members. The screw must penetrate the back of the steel so a minimum of 3 threads are exposed. Wire ties are rarely used, but still a good option. Wire ties are generally limited to commercial projects and then only on suspended cold rolled channeled ceilings. Nails with large 3/8 inch heads are also an option for wood framing. Nails must penetrate 3/4 of an inch into framings. All soffits and ceilings require longer length nails. Typically this is 1.5 to 1 3/4 inches. Furring nails that have a paper wad to hold the lath off of the framing are referred to as furring nails. They are not required when installing a self-furred lath. Self-furred lath means the lath manufacturer has included crimps or other furring devices to meet the code. In some cases, the furring nails are unsuitable for some laths, such as expanded metal or rib lath. This can also impact the nail penetration into the framing members. This is an example where a professional lather should have pointed out to his supervisor the furring nail is not the right fastener, and then do as directed. Before you start hanging screeds, paper, or lath, you should walk the wall to verify it's ready for lathing. Keep two things in mind while you walk the work. They are backing and flashing. Backing is the support system for your lath and must not only support the weight of the stucco system, but be able to withstand the stresses the stucco will be subjected to. The item to verify is the wood framing is straight and dry. Wet wood will tend to warp and twist as it dries out. This will likely crack the stucco membrane. Twisted framing should be replaced. Proper terminations and backing for the ends of the lath are important. Seeing any areas of concern should be reported to your supervisor and then proceed as directed. Most areas requiring backing can be spotted by merely walking the project site. However, their vertical trim accessories such as reveals and control joints will only be able to check with a review of the plans and elevations. These trim accessories require vertical backing to terminate your lath. You will only know where they will be placed by looking at the plans and elevations. You should review those plans and elevations and note vertical trim accessories that are not aligned with obvious framing members. This is generally in the field of the wall. You will need to verify the required backing is in place to support the lath termination or ends. The importance for backing is critical for reveals, control joints, and expansion joints. The lath shall be cut and must be backed by framing members. Horizontal joints are supported by the standard spacing of studs with no additional backing required. However, failing to have the required backing support for both ends of the lath on vertical oriented joints can lead to cracking on vertical trims. For reveals, the hairline crack will generally follow the unsupported flange of the reveals. The unsecured flange of the vertical reveal or expansion joint can twist and move during seasonal changes or other stresses. You must note the failure of required backing for all vertically oriented trims. Notify your supervisor that the backing is missing and then proceed as you are directed. Be professional, protect your company, protect the industry, protect your working future. One of our more controversial issues is the vertical one-piece control joint and whether the lath may be continuous or is required to be cut. ASTM states the lath shall be discontinuous behind joints. On many occasions, the designer opts to reposition or may not make a final determination for the joint location until well into the construction phase. We know the lather must attach the lath 7 inches along framing supports. Owners and designers often select the location for the control joint based on aesthetics, and they may or may not land on framing members. All professional lathers must know that vertical ends of lath terminations must be attached to framing members. Simply cutting the lath to comply with ASTM could be problematic. This is because if the support or framing is missing, the vertical lath end is classified as unsecured to framing. When the lath is cut, and left unsecured to framing members, the stucco membrane becomes vulnerable to stress. This is particularly true in climates that experience more extreme temperature swings. The cement can move or curl away from the wall. The cause for panel lift at vertical joints is the unsecured lath. Site investigations verify this occurs in the field on projects when the lath is cut and there's inadequate framing. The SMA recommends that on all vertical joints, even one-piece control joints, have framing behind the joint to comply with ASTM. However, we know this is not always possible and recognize a workable and proven solution. The SMA recognizes and will support the installation of vertical-oriented one-piece control joints over continuous lath. This keeps the lath secured to the framing members and does not diminish the effectiveness of the joint to relieve stresses. The SMA has supported the option of one-piece control joints over continuous lath and will continue to support this position to provide a better and more functional stucco wall assembly. The SMA also supports ASTM prescription for discontinuous lath behind control joints, but only when proper backing is provided by the builder or framing contractor. Backing for lathing and concrete masonry substrates is not as challenging as it is for framing. Often lath is not even required. When cement plaster is to be over 5/8 of an inch thick, lath is required by the building code. Attachment of the lath to the concrete or masonry can be as simple as using stub nails or power-actuated fasteners. In some cases, greater pull-out resistance may be required. This will require the lather to pre-drill holes and then drive the pins in with a heavy hammer. Always review the fastener requirements and pattern with your supervisor. In general, fasteners over solid masonry or concrete should not exceed 1 per every 2 square feet of area. Masonry walls should have the fasteners placed in the grout joints. You need to verify the flashing has been installed to ensure the stucco assembly will be weather tight. Flashing is defined as a thin material that is resistant to water penetration and used to keep water out or redirect it as desired. Flashing may be exposed or embedded. Flashing is critical for a lather to understand how the flashing works and industry-accepted practices for flashing. There are many products and methods with regard to flashing. Some are regional based on weather, and the SMA will cover some basic rules to follow. A professional lather will have a discussion with his company and follow that company's established protocols. The field of the stucco wall is rarely a place for water leaks. Leaks tend to occur at penetrations and around terminations of stucco. Often this is due to a lack of required flashing by others. Common areas to look for flashing before you start are windows and doors, balconies and decks, pony wall or stub walls, roof-to-wall connections, and parapets. We will take a look at each of these in modules 1 and 2. The roof-to-wall connection is another potential leak zone. This area is often referred to as the kickout. This refers to the exposed metal flashing that should be installed by the roofing contractor. However, there is an embedded flashing practice that the lather can install to further protect the building. The kickout flashing is very helpful at directing water to the gutter. However, there are still opportunities for incidental or small amounts of water to enter the wall cavity. If there is no flashing behind the fascia board, the water tightness is only as good as the paper you install against the wood. This can let water seep in. This may seem harmless in such a small amount of water, but given enough time, even the small amount of water will create quite a damage. We can protect this area with embedded flashing. The carpenter who installs the abutting fascia board should install a simple flashing paper behind the fascia. This is added simple flashing that can prevent any incidental water from reaching the wood or framing. Most framers will not be educated in this area and consider it not a concern and likely not care. The lather can slip a piece of building paper behind the fascia to provide this extra protection. It should be pushed up as far as possible to ensure your paper will lap and be left long enough to maintain a shingle fashion principle. Looking at this location, the roof-to-wall connection has the required kickout and now has the simple embedded flashing that you slipped behind the fascia board. By looking at the side view of this condition, we can see how this will work. You will run your paper up and under this flashing paper you just slipped in. The paper at the top will overlap over the paper you put in. The side view illustrates the shingle effect is in place with the shingle lapping. If any water gets in, it will be directed down and continuously out. Possibly the biggest issue for plastering contractors is windows and doors in stucco systems. This is with regard to leaks and flashing. They're critical to get right. Windows essentially come in two styles, flanged and non-flanged. Most non-flanged windows are found in commercial construction. They can also be called punched or storefront windows. In general, this style of window should always have a casing bead around the jambs and sill. The nail flange window has a flange that is used to attach the window to the building and is very common in residential and light commercial work. Flashing for each of these windows can vary from materials used to the level of protection required. Your company will establish protocols that you should adhere to and coordinate with the architect details. The SMA has minimum requirements and are based on basic conceptual guides of building science and code compliance. The storefront or non-flange window should be set to accommodate the thickness of the stucco assembly. These mirror images illustrate the proper setting of the window frame on the framing, and the green line indicates the flashing membrane by others that you should see installed. Starting at the right window, you will need to install your 2 layers of water-resistant barriers. You need to slip them under the flashing so that it is lapped by the flashing. You now install your casing bead and leave a gap for the sealant that will come in after plastering. The gap you leave should be clarified in the details or plans. Typically the gap should be no less than 1/4 inch and no more than 3/4 of an inch. You then apply your self-furred lath with furring dimples facing the wall. The plasterers apply the plaster and then the finish coat. The sealant contractor will then install a backer rod. This sets the depth of the sealant joint and assures an hourglass shape to the sealant so it will be flexible. The sealant is applied and bonds to the window frame and the casing bead. This provides an effective and working seal. The joint will need annual inspections and replacement over time. This is part of a maintenance program for non-flanged windows. But what happens if the framers do not set the window, as is pictured? In many cases, you may see the window set flush to the sheathing, thus leaving no room for the sealant joint. You should first talk to your supervisor and clarify the proper direction and action to take. The most likely course of action will be the following. The water-resistant barrier must be installed as it was before, under the sill flashing represented by the green line. In this scenario, this is even more important than in previous examples because there will be no room for a backer rod and sealant. You should have a minimum 2-inch overlap on your paper. Your casing bead is set as shown. The plasterers then plaster the wall. With no room for a functioning joint, the sealant contractor will install what is known as a fillet seal. This is not as flexible as the other style of joint, but it will keep water out. It is possible this joint could fail over time due to extreme stress or aging with exposure to the sun. The concealed barrier and your integration to the sill flashing will add much needed protection in the event of a failed joint. If there is no flashing, you should point this out to your supervisor and then do as directed. The flanged window is preferred by residential builders for a variety of reasons. The fact they can be opened, are lower in cost, and require less maintenance are prime reasons to use the flange style window. These windows should be flashed with flashing strips. ASTM window manufacturers and the SMA all recognize the basic and simplified penetration flashing strips of the nail flange window. This flashing process is not the lather's responsibility, but you must be able to recognize a properly flashed nail flange style window and then install your paper in shingle fashion to ensure incidental water is shed down and out. First, a sill strip of flashing should be installed by the window installer and left loose along the bottom edge as illustrated. The jam flashing strips are to overlap the sill flashing. Prior to setting the window, a bed of sealant should be placed around the entire perimeter of the opening and the window flange is set in that wet sealant. A final head flashing strip is added over the top nailing flange. Now the siding contractor can install his concealed barriers or building papers in a shingle fashion. This requires the lather to slip his first course or row of paper under the sill flashing strip. This is critical to maintain that shingle fashion concept we need. The rest of the paper is then applied with laps of a minimum 6 inches on vertical laps and 2 inches on horizontal laps. This concludes Module 1. You should better understand backing and flashing for lathing now. Module 2 will cover the actual practice of lathing.